and to be able to share the demos. So Shan's going to record for us. Let me just share screen.
Nick is going to record for us, but thank you, Nick.
Okay, can everybody see that? I think so. Okay, guys, so thanks so much for joining us tonight. Tonight, we're going to be doing our EskomSePush OfferZen build challenge demos. This is gonna, yeah. So this is the face that you make when you're hit by load shedding, guys. So we're really happy to welcome you guys here tonight. Just some context, we launched this build challenge 2 weeks ago with the EskomSePush guys. Our goal was to do something fun with the community, and also almost every conversation you have involves something about load shedding. So it's pretty topical at the moment. And the EskomSePush guys have been doing some pretty cool stuff. They have a new API that they released about a month ago. And so we were keen to play around. We got the community access to the API to be able to play around and build. And tonight we're going to be exploring what you guys have built and having some fun together. So our agenda for the evening, after I'm done, I'm going to hand over to the EskomSePush guys, and Dan's going to take us through a little brief intro about them and share some of their history and what they've been doing. And then we've got 6 demos lined up tonight from various community members and some new faces as well who've joined us for this build challenge. And they're going to be taking us through what they've built and some of the challenges they faced in their building and what were the problems they were originally hoping to solve. There'll be an opportunity for us to give them some feedback and also ask the guys some questions as well. And then at the end, after you've listened to all the demos, you get a chance to have your own vote and decide on your best. So that will happen at the end. Okay, so I'm going to hand you guys over to Dan. I don't know if you guys have met Dan, but he's one of the really cool guys from EskomSePush. Okay, Dan, I'm going to hand screen sharing to you.
Awesome. Cool. Thank you so much for the introduction. Yeah, so it's me and Herman, who's also on the call. The other half of the light bulb picture. It's actually funny seeing that picture. It was a picture we did for the Sunday Times, I think back in 2015, and it was like one of our first press photos, and it was like massively embarrassing, and we were in a little like crappy cafe in Techno Park, and we're standing next to a light bulb while some photographer was taking a picture of us. So we've had a bit of an interesting journey. But yeah, enough of my rambling. Let me share a screen and then we can get this started. Cool. Okay, cool. Well, let me give it like a quick brief introduction on EskomSePush and our API. I think you know most of it already. And if you've got any questions, I always say this on any talks that I do, like we are so used to getting feedback all the time that if you would like to heckle me during this presentation, you're welcome to. I'm completely open to it. Like you can throw things at me, you can swear at me if you want to. That's fine, as long as it makes you feel better. Like then that's great.
Me, Dan? Can I also do that?
Yeah, that's perfect.
Okay.
It's even better if it comes from you, because then it also encourages other people to swear at me. I'm open for that.
The funny thing is the first time we're doing this type of thing together, so it's actually gonna be fun.
Yeah, no, that's it.
Like, no, Dad, that's bullshit. That's not. So yeah, let's see. Okay,
so an introduction into our inner workings. Basically, this is how Herman and I just spend our days. So yeah, OfferZen, awesome company. EskomSePush, doing some build stuff. Awesome. So yeah, what is EskomSePush? I think we all know what it is. We take the mess that is the various different load shedding schedules that you would need to basically, print out on A3, A1 size paper with a highlighter and a ruler and work out, what slot, what stage, what time, what block am I? And we take that across all the different municipalities and put it into a common format. So you've all, the folks here that have been involved with the build challenge have seen the API and you've seen the data that comes back. It's consistent across all the different municipalities. You're getting similar data back. You don't need to go and look, you don't need to know that Mfuleni is so strange, that Umhla has got only 4 stages, that Nelson Mandela Bay changes their schedules once a month, that so does Umhla, that eThekwini is not affected between stage 1 and 3 because of all the floods. Like, you don't need to know that stuff. Like, EskomSePush is doing all that stuff. And then also, one thing is having the schedule. The second thing is actually knowing when a stage is going to kick in, stage 1, stage 2, stage 3. You know, and that impacts it, you know, it does the impact of when you're going to be affected in the schedule. So you can have the schedule's pretty easy to capture. It's the, like, you know, when are the stages actually going to be impacting you, and can you, you know, use that data for something interesting. So ultimately, yeah, EskomSePush, push notifications for Eskom schedules. That's the name. I don't know if anyone has any other theories behind the name, but that's the name. And yeah,
What I read in one of the articles about you guys, Dan.
yeah. What did you hear?
I don't know if I want to say it on this call.
What did you hear? I'd like to know. We can debunk the myth now.
Let me try to remember. It was something about how, with an Afrikaans accent, something about push notifications that came out as something else. And so you guys picked the name based on that, how it sounds with a heavy Afrikaans accent. Am I wrong?
Yeah, Herman, what do you think?
I think it was Capitec.
Yeah, it was working with Capitec. We were doing internet banking, like containers and security back in the day, and push notifications was a common topic. Saying it with a strong accent typically means sort of pushing the mute button on the teleconference and having a good laugh. But yeah, the name EskomSePush came up. We thought it was quite cheeky, and we ran with it. But ultimately, it's push notifications, which is the technology for Eskom schedules, and then, you know, beyond that, all the other municipalities as well. Yeah, we've become a bit popular. If we send a push notification out now, it goes to, I think it's 6.7 million devices. It brought 2.7 million active users, unique active users online yesterday, and they're checking the schedule frequently throughout the day. That push notification also kicks about the last one that went off now at 4 o'clock. I think there was an update as well. That peaked at about 1.5 million requests per minute on our backend. So it's a lot of traffic. It's a lot of people that want to know when they're going to be affected as quick as possible. And yeah, funnily enough, all these features that we tend to develop. So this one here, upcoming, it helps people to answer the question, when will I be affected, quicker. And ultimately, yeah, that's what we want to do. We want to answer that question. When am I going to be affected? This is some interesting graphs about our user data. This was updated now. This is this year. So we've got this like really, really strange usage graph. Obviously, it matches to when there's load shedding and not. So this kind of ties into where we want to maybe go in the future, as we want to try and flatten this out a bit by building out on the Ask My Street features. But that's something we're still iterating. And then, yeah, 2 interesting stats. 18 to 24-year-olds clearly don't like planning, and majority of our users are female. So I don't know, draw any correlations there that you want, but that's some interesting things we see in the user data. And then, yeah, we're just 2 people. We're doing this full time. Hammond's been working on it full time since January, and I've joined in August. We used to work in, you know, software engineering, and we were like people managers, and now we're doing this full time. So it's quite nice not having anyone report to you, I won't lie. And here are some of our frequently used emojis. But yeah, maybe before we go into the demos and pass on from there, just can give you like a quick overview or like values of some of the things that we've learned while doing EskomSePush, because it's like, it's this thing, it's a service that we provide to South Africa for free, right? So it's an app that is for free. You can go and get the information. We want to provide the information as quick as possible. However, you know, anyone can do that, really. So what makes us interesting, or what makes us unique, is we think it comes down to these things, and these would be kind of like our company values, and kind of be the things that we've learned. And Herman, just jump in where I'm bullshitting. But one of the main things is like, have a community, understand your community, and also be patient with them. And also like have a taste for solving their problems. So don't try and push a solution onto them, but like understand their problems, and build things for them. Iterate fast and stay lean probably go hand in hand. Start small, fail quickly. Don't spend weeks building something and you're unsure it's going to have value. Rather launch it quickly to a small group, and don't invest too much energy into it. Fail and don't be too attached to it. Get some good metrics out of it, understand what went wrong. And then the last one is like, do you build a fan club? And that's really, stick to your brand, build a brand, and then also have fun. Like there's no point working on something if you're not having fun. And also, put your name on it. And we've done that fairly well with EskomSePush. Is we like to remain in the front with EskomSePush as like our product, but it's also EskomSePush, and then and the next thought that follows, like, oh, it's Herman and it's Dan, So we are building a bit of a fan club around that, and the reason for that is like, actually we want our fun and our cheekiness to go into the app, because it makes like a handful of people laugh, and really that makes our day. And then about the API. One thing that we launched a couple of months back, is the API. It's probably it was my first new feature since joining the company. Was the public API and the personal bit. We've had a business API for a good couple of months, but this is the next iteration of it. And it provides some of the data that you can get out of the app, if not all of the data that you can get out of the app. Basically, to answer that question, when will I be affected? So yeah, that's kind of us. The one thing there that I see Herman mentioned is the socks. Would you like to talk about the socks, Herman? No.
No, I would just say we don't make money from the socks. The socks is sort of a escape, because a lot of people think we like load shedding. We really don't. I think there's like levels of people that hate load shedding. Maybe we're not at the top. Maybe there are people that hate load shedding more, but we're like up there. And like the socks is something of an escape. Like, okay, let's do something creative that is not load shedding related. Yeah, so yeah, buy the socks, or give it, like, it's a good time for buying Christmas presents now before the prices go up. Go buy it for your friends and family. I think it's a good idea.
Awesome. Yeah, that's me. That's my presentation. So yeah, I'm looking forward to seeing some of the demos.
Thanks, Dan. Okay, now back to me. Too many screens. I think you guys can see it. Okay, cool. So now the really fun part is we get to see all the super amazing things that everyone has built. So as I said, we're going to have 6 demos tonight. This is our schedule. A lot of them are teams, which is quite cool to see. A lot of people working together to produce some really awesome stuff. So the demos, everyone gets a 10-minute slot. So that's a 7-minute demo. And then there's 2 or 3 minutes. We'll get some feedback from Dan and Herman on the build. And also you guys can ask each other some questions and give each other feedback. So I'm going to hand over to our first team, which is Personal Trust, which is Brandon, Balaz, Justin, and Murray. Okay. Brandon, I think you are doing the demo for us.
Hello.
Can you hear me?
Yeah.
Cool. And let me know if you can see my screen.
Yes.
Is that my slide?
Yes.
Cool. Cool. How's it, guys? My name is Brendan. The team of us was myself, Balaj, Justin, and Murray. Myself, Balaj, and Justin worked for a company called Personal Trust. We're an investment company based in Rondebosch in Cape Town. Murray is based in Cape Town as well, but works for a UK-based company called InStyle. Yeah, let me just crack on with it. So our problem statement, since COVID, obviously us as a company, a lot of our teams are working remotely. Everyone is affected by load shedding differently, and with the status always changing, obviously it's difficult to keep track of how our fellow teammates are affected. The work that we do is very deadline driven. And so when staff are not available, it's essential that a colleague is in a position to cover them so that we can meet our deadlines and keep up our service delivery for our clients. The tech stack that we used was Python with Django as a web framework. We used Celery for background tasks, which I'll get into just now. And then on the front end, we used HTMX and Tailwind CSS and everything containerized using Docker. I'll start off just by, I've pre-recorded the demo, so let me just play that and send you through it.
When a user logs into the application, they will be redirected to this page. This will allow them to see any of the teams that they already belong to and navigate to their dashboards. Otherwise, they've also got the option to create a new team or to join an existing team. We really wanted to get the reactiveness that users have become used to when working with front-end frameworks, but we didn't have the time or the resources to implement a framework. So we've just gone with Tailwind CSS in the front end. And what was quite exciting is the use of HTMX to build out our reusable components. So everywhere you see a form on the application, we're using HTMX to go to the server and return that form back into one of these modules. And we get that real-time validation without doing any page refreshes. So we've used this all throughout our application, which has made it quite easy from a development point of view. So I'm just going to go to my OfferZen team, which I've already created. That'll take me straight to the team dashboard. I've signed in as Michael Scott, but you can see that I haven't set an area yet, so it's telling me that at the top right. But I can still see the load shedding status on the right-hand side and my list of teammates down below. So on the right-hand side, we just see a banner that shows the stage for South Africa as well as Cape Town, and it's also showing when we can expect that stage to change. To go and update my area, I will click on schedule, which will bring me to this page where I can search for an area, which will do an API call to EskomSePush and return the search results. And I can then click it to add it to my profile. And you can now see that I've got the schedule for the next week for Sunnydale. We can then go back to our dashboard or one of our other team dashboards. And we've just hit 4 o'clock at time of recording. So we can see that South Africa is now currently stage 3 and Cape Town is stage 1, goes down to stage 0 at 12 at night on Thursday. Here we can now see our teammates who have load shedding still scheduled for today or tomorrow. You can see these ones with green icons have no load shedding planned. We've got Andy Bernard who has load shedding today at 6 o'clock. And we've got Kelly Kapoor who is currently load shedding in Belleville. I can apply filters here to see who's load shedding today. There's a list of all the teammates who are load shedding today, as well as the time slots for when they are load shedding. This will take the events that come through from the API for each area. We can also see if there's anybody load shedding right now, and we see there's 3 of them. And we can also just go back to see a list of all of them. We've also got the search functionality as well. So if we see Michael, we could then see Michael's status, and he's on stage 3 with load shedding at 6 o'clock. We've got these cards at the top of our dashboard. 2 of them are call to action. One's just a quick and easy way to go and add another team. The other is a way to just go and add or to invite a teammate where we can just put in the name and email address and we'll send them an invitation by email. And then we've got this stats card, which currently is just a placeholder. Unfortunately, we ran out of time to implement that. But we thought since now we were incorporating our team's data into the application, we have all of that data and we'll be able to keep track of historical data as well. We thought we could have some fun and use this as an opportunity to start bringing in some metrics, such as allocating a value to a teammate or an employee and to see how much the business actually loses out by quantifying that and creating a dashboard to see information around that and to see if there's better ways to structure the team when there are days of load shedding. Other than that, that's a wrap. That's a rundown of the application, and logging out is as simple as that.
Background design of the application. You've obviously seen the user flow that's there, and we've got a Postgres database on the back end storing some of that data. Unfortunately, I mean, we wanted to try and use the API solely and just use the database for storing users and their areas. But I mean, I'll go into some of the challenges that we faced just now. So the design that we have here is that as a user logs in, and they add the area, they make a call to Eskom API, as I showed you in the demo. That area is then stored in our database, and we then use Celery to run some cron jobs just to check for status updates. Obviously, that can change at any time. So we run a cron job against the general status API to see if the status has changed since the last time the cron job ran. If the status has changed, we then run other background tasks just to go and get back the latest information, the latest events from each of the areas that we have in our database. The challenge that we encountered was obviously to get as you saw in the application, what was quite useful for us was to see the upcoming events for each area. But to get hold of that data, the only way we could do that was as far as I understand, the only way we could do that was by querying each area information. So we really had to loop through the areas that we had and get that information one at a time. So I mean, what we would see as a nice enhancement to this, so that we could rely purely on the API, is to get back all the latest events just with one API call whenever a user lands on that, so we don't actually have to store that information in our database. And then one that's probably not as easy to solve, but we obviously need to run a cron job that hits the API every so often to check for the status. If we could have a push notification or something to notify us of a status change, or sorry, moved forward, to notify us of a status change without having to run that cron job, then that would be quite useful. What we learned, the first thing was how rapidly a small team can pull something together with the right tools and collaboration. I mean, we only submitted our application on Wednesday and started discussing it on Thursday and started developing it on Friday, and only then realized that it was due on Monday. So we scrambled over the weekend, but we got something together. And yeah, it was quite an awesome experience. The other thing we learned was just the value in using HTMX and Tailwind for rapid development without a JavaScript framework. Obviously, with time being of the essence, we just had to keep it as simple as we could, and HTMX made it really easy to do that, as well as Tailwind. We managed to get some really nice looking designs in a very short space of time. What's next? We'd like to see some improvement on the company analytics. As I mentioned, that was just a placeholder, but since we got that data there, it'd be interesting to see if we could quantitatively display how load shedding might affect the business or a team, and see how an application like this or EskomSePush could help a business in sort of improving those revenues. We'd like to integrate with Outlook or Google Calendar so that we could let users know when they're setting up a meeting with their teams to that they might have a team member who is affected by load shedding at that time slot, and to suggest rescheduling for another time, and a daily, sorry, I keep on doing that, a daily roundup every morning, just letting users know who in their team is affected for the day. Yeah, and that's it. And the rest is just our details and a link to the project.
Thanks so much, Brandon. That was super cool. I really, really like your analytics side, especially for a lot of businesses who have to make a decision of like, should they invest in a generator, to actually have a way to see how much money you're losing and how much efficiency you're losing is super useful, I think. I'm going to hand over to you, Dan, if you have some feedback to give. Or Herman.
I can go. So I am super impressed with the UI. Like, it looks really good. Like, is one of you a designer or something? Because I just wanted to give kudos.
Murray gets all the credit for that. He put all that design
super good
at the front end as well.
I really like it. The look is amazing. I'll have to check out HTMX and Tailwind now. I made a note about that. But okay, so you started on Friday and the due date was Monday. So how many hours did you actually spend on this, right? Like, was the weekend basically a blur?
Probably not as bad as it should have been. I mean, also Django just is one of those tools that just makes development really, I mean, that's why they say a lot of people use it for prototyping. It was just a way to really get everything together so quickly. Murray was like a ninja on the Tailwind as well, so those designs came through so quickly. But we still had our beers on the weekend and relaxed when we needed to, and Yeah, so it was a bit of a
That's where
late.
the good UI comes from, clearly, I see.
Yes.
That's the thing with Tailwind, it actually just makes it so easy. I haven't got a huge amount of experience with Tailwind. And again, I think that speaks to the effectiveness of it. Just being able to plug things in, find components online and just kind of, tweak it and bend it to match the actual design. I really was impressed. It was very cool to work with.
Cool, guys. I look forward to seeing what comes out at the end once you've added all the features, especially for me, that's the Google Calendar integration, I think is a super win for business people.
Awesome.
I don't know if there's anyone else in the community who has any questions or comments they want to add before we move on. I don't know, you guys can hear my small child shouting in the background. Sorry. He's discussing with his father about whether he has to get in the shower. Okay, cool. Brendan, can you stop sharing? Our next team member is going to be, we have Devin up. Can you guys, oh, I'm on the wrong one. We have Badgelife coming up, and Devin, I think you're doing the demo for us.
Yes, that's correct.
Cool. This team was Devin and Tommy, and they did something pretty different. So I'm super excited to see this.
Just let me see if I can get the slideshow right with Google Slides. Never done it with Google Slides.
Yes, we can see.
Is it full screen now for you guys?
Yeah, big enough.
Okay, perfect. Okay, cool. Yeah, so our team is myself and Tommy. We live in Randburg, and funny enough, I'm more of a developer, and Tommy is actually a pilot who loves to tinker with hardware and electronics and boards. We usually like to fly racing drones, so we've been quite used to like circuitry and things over the last few years. We obviously fix stuff when we smash it into walls and whatnot. And yeah, we often have lost a few items to load shedding, electronics blowing up, things just not behaving right. And so we wanted to create something a little bit different to what I believe everybody else would do. Instead of us just doing a software solution, we decided to build something physical that you could put on your desk, on your wall, and be able to see what EskomSePush is putting out. And so over the last 2 weeks, we sort of spoke to a few people, and we often saw some people who maybe were just not capable of using the app, or it just confused them. And so we thought, yeah, like, why not build something that is a little bit more interactive and doesn't require you to have a smartphone in your pocket all the time. So that's what we thought. In terms of the tech stack that we use, just before we show you the actual badge and the cool parts of it, we built like a little middle layer currently that consumes the EskomSePush app and the data, and we basically just cache it on there so that our little microcontroller can sort of talk to the server more often. So maybe every 5 seconds to every 5 minutes, we could get sort of quick iterations on that. And so we decided to use this little electronic board, which happens to also be called an ESP. And we programmed that with C++. And so, yeah, that's how sort of that technology stack was put together. Some of the stuff I already mentioned there periodically syncs. We used mainly the status and the area endpoints, and the Node.js is basically doing the hard lifting. And then what we did, because time was sort of a little bit shorter for us in terms of doing a hardware build, we created the badge as sort of more of a dumb device. So we basically just tell it what to do with no real sort of it doesn't really have any brains on it currently, but it's capable of actually speaking to EskomSePush direct and handling all of that. So that was just a bit of the details there. And then here is sort of our renders, just to show you guys what we built. So this is a badge, and what we did is we put 19 LEDs on it. We just, as we had short time on it, we wanted to sort of make it as sort of flexible. So we put 8 lights for the current 8 stages, and then we put another 11 on the outside to be able to be used in any fashion. And so what we did currently is we sort of put, different colored LEDs, and those can be programmed to suit. So currently we have it where, like, it's not very intuitive, but it will count down the 11 LEDs based on the time like left. So every half an hour, one LED will come off, and it will go down until it counts down to the end of or the start of the stage, the stage of load shedding. So this was that rendering. We've actually ordered some of these boards from China, but given only like 7 days, it's in the air, and we should see them probably Monday next week. So we'll actually have physical ones available. We have all the parts that's here, all of the parts that you see in the pictures. We've ordered all of the different parts, and we'll be able to put 10 to start with if anybody wants one. And then sort of some of the challenges that we faced was obviously manufacturing time. So as soon as you go to hardware, obviously, things and complexities go right out the window in terms of having to deal with the hardware, the software that talks to it, and obviously ordering and being able to get all the parts. So like on this particular board, we've ordered parts from, I think, 4 different locations, in multiple countries to bring in all the parts for this. And then other little things that we had on the board itself was that handling JSON and datetime calculations in the C++ on the Android. I mean, on the Arduino, the source code that runs that little guy, those calculations were really difficult. So like if you take how the time comes through from the API, we have to like sort of convert those to timestamps, then check across, and that gets quite complex for us to do that on the C++ side, and that's ultimately why I put the little node app in between, was to buffer it so that we could make something quickly. But ideally, what we really wanted to do is that this device is a standalone device, and you can just plug it in, you open it, and you go to your, like using Wi-Fi, you connect to it. It's got a little web app, and you put in all your details, and then it would just connect. So you wouldn't need any sort of third-party software in between us and EskomSePush. Yeah, and one of the other random problems we had of late was that we weren't quite sure what we wanted to do with the LED sequences. So currently it's like a very flat, bland sort of display, but we really wanted to open that up for everybody who wants to play around with it. You have the capabilities of, playing around with that and setting it however you want, and yeah, putting that out. Next steps, basically documentation still a bit rough. We've got to assemble those final boards and yeah, optimize the current code, as well as we want to do that serverless version, so everything's on chip instead of having a middleman. And then the one thing to ask from you guys, Dan and Herman, was like some sort of ISO formats on those the grid times, from the timestamp, the start and the finish. That would just help us maybe with changing the complexity of the date time calculations. Not a big thing, but I don't really like C++ myself. So yeah, And if anybody wants to contact us, that is my username on Slack, as well as our email addresses and the URL for the for our GitHub repo, which has got the board schematics. It's got the sketches that go onto the ESP 32 device and all the cloud code as well. So everything's there. And then a link just to the little microcontroller that we've used. So yeah, I don't know if anybody has questions.
Yes.
Let me stop sharing and I can just show you our breadboard. We put one together for just to show you guys. So this is the 8 LEDs for the stages. I mean, you can't, the blue gets a bit intense, but it's third one down, and then this is counting down to like this another hour before this load shedding set is about to start. So that's what we put together so far. Yeah.
That's super cool, Devin. As someone with children, a little child who loves to watch TV, constantly being asked, when will the power be back on? It's like, okay, watch the lights. There are some questions here in the Slack before I hand over to Dan and Herman. Bongani has a few questions. He asked, like, will the LED boards be installed next to the DB units or the meter box?
They use Wi-Fi. So obviously, currently, one would need to be connected. But that's something that we can expand on, is that we looked at putting, they do actually have a battery. So we were expecting they can do about 6 hours, so as long as you've got Wi-Fi, but we're looking at, that can be enhanced, that they've got enough data to be able to, stay disconnected and work for a whole load shedding schedule. So, yeah.
And Herman and Dan, do you guys have any feedback?
I have a lot of questions. So have you thought about adding sound, like or vibration? Because I think like my first thinking when you were telling a story about how you came up with ideas, like old people, right? So old people, they don't have smartphones, and it'd be amazing, like for example, vibration or a sound that goes off that okay, power's going to go off in 55 minutes. Also, that's my idea for maybe the circle is a countdown, like 5 minutes, everyone, like an hour, right? Because I could see there's like almost an hour there. It's pretty cool. And then how does this thing connect to the internet? Like, how do you set that up? Because I'm assuming that might be quite tricky, like connected to Wi-Fi, or is there?
So you want to answer this over side?
So basically, when you first power it up, it gives you an access point that you can connect to with your phone or your computer. Once you connect to the access point, it's going to ask you to connect to a Wi-Fi network. And you basically put in your SSID and your password. It will connect to that. And then the final one will have maybe the API key and the region that you're on and the block that you can put in, like Randburg or North Riding or something like that. And then it will automatically connect to your network and go and fetch the data of the credentials you added in.
Nice.
And then, when the power goes off, we're hoping that we can cache the schedule. So even when the power's off and you don't have Wi-Fi, it still has the battery, it still has an internal clock. So it will still count down to when power can come on again. And obviously, if the power comes on early because load shedding was suspended, then it will connect through the Wi-Fi again, pull that data, and then carry on as per normal.
Makes sense. I like it. I like it a lot. I like the design too, by the way.
Yeah, sounds like Dan ordered all 10 of yours, Devin.
Yeah, I want all of them. Herman, do you think we could sell these more than we could sell socks?
Can we sue them for using our brand? I thought that's what you're going to say. Like, we're gonna take all of them now. Joking.
No, I think it's an awesome idea. I really dig it. I like Herman's comments about using sound, especially for someone that's visually impaired. Also, a thought is instead of making the actual ESP32 too smart, is to just have like a QR code or UUID, something like that, that's scannable on the back of the device, and then it always just connects to your server. And then you actually have a UI console, like management console, hosted somewhere where you can update your area ID and any config for the device. So the device is always connecting upstream, and then it gets its config from something in the middle. And that could be your serverless thing that you're talking about. But I dig this. I think this is very cool.
Yeah, so I mean, all your options there. Just to touch on like the hardware that you asked about, one can put vibration. Vibration motors, like a really simple concept, is just a sort of a digital on or off. Sound as well. These guys can do sound like analog. You can play an MP3, if one wanted to. So it's capable. This what we really wanted to achieve here was to whet everybody's appetite as to like what you can do with with a bit of hardware and 7 days. Yeah,
I think you definitely did that really well, Devin. I think everyone's super interested to see what you can do. Okay, we're going to have to move on to the next demo, but feel free to keep asking Devin questions in the chat, and you can always stick around the end and ask him some more questions. Our next group up is Animaniacs, and Eben's going to be doing a demonstration for us.
All right. Hello, everyone.
Hello.
Okay.
Hello,
ladies and gentlemen. Yeah, thank you. Hello, ladies and gentlemen. This is the Animaniacs, and this is our EskomSePush challenge. So to introduce you to our team, it's Eben Kok, who is a senior software engineer, Brons van den Broek, who is an intern software engineer, Isaac van der Hoeven, who is a senior software engineer, and we all work at Glue Code, and we create some awesome apps. Okay, a little bit about us. We live in Gauteng, South Africa. We like to build apps, go on hikes, tinker with 3D printing, and we love electronics. And we find that the most annoying parts about load shedding is that the traffic doesn't work, we can't cook, and it interrupts our all-night gaming sessions. Okay, moving on to our problem statements. Some of us on WhatsApp groups, and people are constantly asking where they can find zones and what zones they are in, and whether or not we know of surrounding area schedules. It would be quite useful to see affected areas around the map and their current load shedding schedule. So why did we tackle this? Well, we like a challenge and maps are cool. And our tech stacks use is Kotlin multi-platform. We use MapKit with Swift GeoJSON and SwiftGR, which we programmed it in. Okay, this is a small prototype, which I did just last week, Wednesday, just to get the general style of how we wanted the app to flow. And now I'm going to hand over to Eben Kok to continue this presentation.
Cool, thanks, Bronson. Yeah, so as mentioned, the app was built in SwiftUI, but our network was built in Kotlin, or Kotlin multi-platform. And I'm just going to quickly hand over to Isak to just explain that a little bit in some detail.
How's it, guys? So first off, yes, I do actually have load shedding right now, the irony. So I was actually planning on doing my own submission, and being an Android developer, I naturally built my network stack in Kotlin. But also, these days I'm very obsessed with Kotlin multi-platform and the idea of sharing code. So when it turned out that, I wouldn't be able to submit my own submission because of work deadlines and life things, what I did do is I put my repo in, I put my code in a Kotlin multi-platform repo that's available publicly. So if anyone wants to check that out, we'll be sharing that at the end. But the idea is that network client is pre-configured for logging and for authentication, and it can just be plugged into an Android app or an iOS app for that matter, just using GoCoPods. So yeah, hoping that made the lives easier for the guys.
Cool. Yeah. Thanks, Isaac. I think it definitely did. I think if there's one thing that front-end people don't like doing is, boilerplate code and back-end development. So yeah, so the premise of the app, when the app launches, we have to obtain the data or the current status, and that's where the API comes in. Then we allow the user to select a province, and that was one of the first challenges, was finding a data set that we could overlay onto the map. Firstly, we had to find a data set that was free in short notice. I think we all suffer from just-in-time development. So, we all started also Thursday really late and a lot of time spent over the weekend. But I happened to find a data set, and I'll share the link as well, that we could then overlap. The problem with that as well is that these data sets, although small in text size, is massive on a map. So what happened is we got a GeoJSON file that was about 5.3 megs, and I mean any PC laughs at that. But if you overlay that on a map, it just kills the processor, and you could really see the processing power just jump to 100%, just flatline. So we had to break that up, and there were about 4,227 words inside this file that we manually had to split out, and that's where the different areas came in. So we split them up into the different provinces, and that lessened the load to somewhat. There's some improvements we can still make there, but yeah, nonetheless, found a free data source, was able to plot it on the map, and that was part of the challenge. So having done that, the user now can select the province, which then overlays these GeoJSON polygons. And then the next thing was to identify these polygons and find a way to map them back to the Eskom API or the EskomSePush's area IDs. So what happened is, luckily these data sets have got IDs. So what happens is when you tap on it, we take the ID for that specific polygon. I also record the location or the GPS location for that specific area, then make a call to EskomSePush's API to get the areas for that geolocation. And then at the moment, we're just assuming the first one is the correct one because of the rank. And then we map the polygon ID back to the Eskom API ID, which then gets also persisted into a JSON file that is stored in the application's documents directory, so that we don't have to make that call again when you do select the same data. And then from there, it's pretty straightforward. Once you have the EskomSePush API key for that area, we just make the call to say, give me the current status. And then based on the status we got previously when the app opened, we map it to the current schedule. And then that's how we basically display the data here. Yeah, some of the challenges I've mentioned already, but plotting and making these overlays on the map proved to be quite interesting, just because of the amount of levels we had to filter through. And I think the other thing is the API, EskomSePush API that you guys built is really great. It works well for your app, but I think if you want to zoom out, we have to make a lot of API calls to get all the data sets, all the data points. And then, the hierarchy of the data, you kind of had to assume the first index of the schedule is stage 1, stage 2, stage 3. So yeah, and the last thing was just building things in time, right? We found out that we were running out of time really quickly, and woulda, coulda, shoulda, we didn't, but I think it was still a lot of fun, and some great learnings for us. So what is next for us? We'd like to really have a heat map, but we'd need to obviously consult with the powers that be that control the API, because it would really be useful if you can give a radius, and it will give you all the areas in that radius in some shape or form, because then we can build a proper heat map of that. And then obviously there's some UI improvements we can make. One of the ideas we also had is to have a slider, and as you progress through the slider, it changes the zones to see how it affects the areas around you. And it's just interesting to see how areas around you and how they bundle the schedules, right? How they bundle the load shedding, because I don't think we get to see that, and that would be a really, really interesting thing to see. Yeah, so that is really us in a nutshell. There's our contact details if you really want to get in touch. We couldn't take a photo together, so we mashed up something at the moment. Yeah, so as Isak mentioned, there's an API client that you can go and get on our GitHub page. You can also get access to the app, and then there's a link to the spatial data that I was able to find. I found it on, I think, Thursday or Friday, and then I lost the link, and I had to go back and kind of scour the internet to find that link again. But yeah, that's it in a nutshell.
Thanks, guys. Thanks for an awesome demo. And Bronson, thanks for the beautiful slides.
100%.
Herman or Dan, do you guys want to jump in?
Okay. So for me, this is of course something that is a lot of people also ask for. So I'm like, okay, yeah, this is cool. maybe I can use it. But the one thing that we've seen is it's really painful because how Eskom or the municipalities do load shedding do not always match the geographical area, right? So, for example, I know in Cape Town, famously, there's Paro. Paro has 2 zones, even though it's just one area, right? So then there's a similar name for both, and there's a few of them like this. So I wonder if you, I mean, I'm sure you haven't thought about this for too long, so it's okay if you don't know, but do you know how we could maybe adapt these polygons basically? If we learn, okay, this is actually 2 areas, right? Like then we can sort of split them, because what we found is there's only City of Cape Town has good polygons for the load shedding areas, but out in the City of Cape Town, it's not really available.
Yeah, it scales quickly, right? And yeah, I think if we can cut up those polygons. So another thing is, if some of those regions, you might have 2 adjacent ones, but they've got the same area ID from your API. The implementation we wrote would do exactly that. It will map it accordingly. And I think the easiest thing would be to just go onto a map and demarcate those areas, drawing a polygon, and then just supplement that into the existing data set, because it's just an array of points, right?
It's quite hardcore, like data wrangling that, but I think it will be cool. Like,
I'm keen to give it a try if you're keen.
Cool. Yeah, so currently we use 2 ways to determine. So if you go to add area, you'll see that we give like the recommended areas, and that is based on what did people add in a 1 kilometer radius around you. So basically around you, what was popular. And then we also have sort of just using similar data, not the same source as you did, but similar data. We kind of say, okay, say for example, Paro, what is Paro's sort of geopoint and radius, not the whole. So we have that data. So that's also maybe something that we can share.
Cool. Yeah.
Cool. Looking forward to see what you guys come up with next.
Yeah.
Okay, our next team, or actually our next individual, is Nicholas. Nicholas, I'm not exactly sure how to say your team name. Is it Afrikaans or English?
Hello, can you hear me?
Yeah.
Yeah, it's just Sasol Papo, so like the garage. I can maybe give a background on it. So we were playing some games with a friend, and we needed to pause the game for him to go get a par from Sasol. So that's kind of how the name was born. Let me share my screen. Share.
I've had a BP pie. I've never had the Sasol pie. Is it any good?
It wasn't me that had the par, but I'll ask him and see. Okay, cool. Can you guys see my screen?
Yeah, we can.
Cool. So a little bit about me. I live in Durban, and I made this by myself because I don't have many friends in Durban. They're all pretty much in Cape Town or overseas. But for my likes and my hobbies, I mostly enjoy coding and playing games, pretty much like most devs, and then also spending time with my girlfriend. So yeah. And then for load shedding, the most annoying thing, which I think is reiterated throughout this demo, is usually on the schedule on the weekends is quite odd, especially in my area. It's usually late at night, and that kind of ruins the gaming sessions. Or just in general, it occurs at an inconvenient time while gaming. So in terms of my problem statement and my app, I've named it Load Sheddify, and I'll get to that later. So my problem statement is that my phone is not usually by me, might be charging, or it's just on silent, chilling somewhere by me. And so I'm usually miss the EskomSePush notifications, unfortunately. So I might be jamming some games and all of a sudden my power goes off. And this actually happened to me at least 2 times. So not that many, but it still happens. So just in terms of why I tackle it, it's just to have it notified for me on my computer where I don't have my phone, since I don't have it near me all the time. So a good use case here is you're playing a game, you guys are most likely on Discord or something. So obviously a notification on Discord would be handy. So for tech stack, I use .NET 6, which is the latest and greatest until 7 comes out. I'm quite a big fanatic of C#, so I enjoy the .NET lifestyle. And then obviously EskomSePush API, and then I also make use of Discord API to make a bot. And then in terms of my infrastructure, I use infrastructure as code using AWS serverless application model, which is SAM. And then with that, I spin up some architecture and infrastructure. And then in terms of how it works, and before I get to that, I just want to plug in AWS here, since not many people know about this or might not know about this, but AWS and even Azure, I think they do offer quite an extensive free tier for services. So it is quite nice. You can do quite a lot for free and you barely pay a cent, or maybe under 100 Rand, you can get quite a bit at going. So I thought I'd plug this in. And then in terms of my architecture, I'm just going to go over this diagram just to not have text blurring everywhere. So this is just better. So you as a user, you running Discord, you want to know what the status is of load shedding or even subscribe to something. So you would trigger a command, which will then go to a Lambda function known as the proxy function, which is the middleman between Discord and everything else, essentially. So this will go trigger a function, which will then instantly respond to Discord saying loading, and I'll get to that under challenges later. And then from there, it'll now split out the execution to another Lambda function via SNS. So saying now we do help. So a nice simple one. And then from there, it'll then go back, spit out any messages through the Discord API, or send information using a bot token, and then the message gets updated, and then the Discord user is notified again. And then from there, the main one that will be used here is subscribe. So the user can subscribe to a specific area, and then on the hour, every hour, just to save my API quota, it'll then do a scheduled poll and then see if there's any updates. And then from there, it'll go through the Discord API again and send an alert to whichever users have subscribed. So I didn't record a video, so I'm just gonna do a live demo like a mad lad. So I actually have some notifications here that I guess I can show, but I just pre-ran some commands to make it a little bit easier. So he has help. It'll just kind of spit out each command and how they link together. And if you need to add any parameters, then it mentions what you need to do. So there's help status. You can search for an area. So Cape Town, I think we'll probably give a generic huge list, or Summerstrand in PE for a specific area. And then you can check the schedule for that area via the ID, or you can now subscribe to it and get updated notifications if there is anything happening. So for now, I've made it a threshold of a day, purely for testing and while I was doing dev, just to see if it was actually working, and then constantly get some updates. And then alongside that, I added quite a bit of simulated test data in a way to kind of fake it, and then that's another way to test it. So here I use the search. I search for Umhlanga, that's where I live. So here it just puts out the name and the ID, and then you can search for that. And then I searched here for some strand in PE, and that just puts out all the stages. And then you can see the current status is stage 3 in 9 hours. And in this other channel, this was actually an alert that occurred, 6 minutes ago, just as I started, I think. So we can see here this is upcoming in 8 hours. So it is quite a far away, but that just ties in with the day threshold that I gave it, just for testing purposes. So that's pretty much the demo in a very quick route. And then the challenges I encountered, so I mentioned the Discord bot requires an initial response within 3 seconds. And if you don't do that, it just fails with application not respond. There's no response or something. So you need to do that as soon as possible. And the SNS send happens asynchronously, so that's quite nice. And then in terms of development quality of life and the API quota. So I think in the first 2 days, I was already upwards of 200 out of my 1,000. So I then eventually started just getting some test data locally. I saved it, and then I used that to test against instead of constantly hitting the API. And then also I made some easy simulation commands, but I don't think I'll have time to show it. And then in terms of Lambda, if anyone's worked with Lambda in AWS, they probably know about this. So if the function isn't used for a while, it'll go to sleep in a way. So it kind of goes idle. And I can go back to this diagram here. So this thing here, every 5 minutes, I've manually set it for 5 minutes now. It'll do a ping to that function to keep it awake. And that's the recommended way to actually make sure these functions are stay awake and they don't go to sleep. So because if this goes to sleep, this initial response usually fails, and then it's not very nice. And then the bot says cannot respond. And then unit tests, it wasn't really a challenge, but I'm just curious to see if anyone wrote any unit tests. And then the next steps. So it would be quite cool and interesting if maybe the app could possibly do this. So you can configure a webhook URL or something in the app, and then the app can do these pretty much the same notifications. So instead of using a separate bot, we can configure a URL in the EskomSePush app. And then just in general, I need to do quite a bit of better support for the commands overall. So currently you can add yourself, but you can't list or remove yourself. And then just in general, a nationwide status would be quite good on the server. Yeah, that's me for this app. And here's my Discord and other get in touch stuff. And then if anyone wants to check AWS free tier, just Google it. Yeah, thanks.
Thanks so much, Nicholas. As Nick says, the gamers in the community would definitely love this. Dan and Herman, I don't know which one of you would like to jump in. I don't know which one of you is the biggest gamer.
I don't know. Herman, we need an office gaming computer. One idea that sort of jumps to mind is that this kind of could work with like the teams things as well. So like if you have like a team, that would be super cool to have like, you know, hey, you've got 5 people that you always game with, and you all live in different areas, and you can see like, oh shit, you're all going out between 8 and 10, or you're all actually going to be online between 8 and 10. Like that's the slot. You know, that's when you're going to jump into your game.
Yeah, I see actually overlap with personal trust there, right? The teams, sort of the work one, but also the gaming teams. There's definitely sort of overlap there with, I think both would be cool.
Yeah.
Yeah.
Yeah, the interesting thing with work is that it's like, you know, like work you can kind of get away with just having Wi-Fi and a laptop, but like gaming, you like need a really expensive inverter, battery, UPS. Like you're looking upwards of like 20 grand to keep your gaming rig running and your monitors and stuff. So it's like gaming, like actually you want to work out like when everyone's like not affected by load shedding, so you can have your slot. It's cool, man.
And what code did you have in your Lambda function?
Sorry?
What code base did you use in your Lambda function?
I use .NET. It's all made in .NET.
And do you know if that is specifically longer to start up than for example Node or something like that? Because
no, so I actually originally did have everything in Node, and so the way Lambda works is it kind of uploads your entire whatever gets built. So with Node, I found that it was uploading all the Node modules, and each function was ending up being 18 megs. And I didn't want that. And I'm not a big fan of JS or raw JS at least. But the time difference was exactly the same. There was no increase or decrease.
Okay. That's interesting. It's the first time I hear .NET. That's cool.
Thanks, guys. Okay, so we're going to hand over to Andreas as our next individual with his project titled It's Lonely Here.
Well, there was, I was forced to pick a teen name, so it was reflective that in desperation.
Your
it was
team
just
name
me.
of one.
So,
sorry, Andreas. We should have said project name.
let me share the screen and let's get started. And also let me take notes of the time so we don't overrun. Okay, so In terms of me, live in Joburg, Broadacres to be more specific.
Hold
I've
on,
been
Andres,
coding
you're not
since.
sharing the screen. If you thought you were, you're not.
Is it not? Let's try again. It is indicating that I am on my side. Ah, there we go.
Okay, cool. Now
Are we in
can see it.
action?
Yeah.
Okay, great. Yeah, so live in Joburg, Broadacres. Been coding since I was 11 on a ZX Spectrum, so I do love to code. I just don't get time to do that because of managerial type responsibilities. Very frustrating. In terms of load shedding, interesting question. The most annoying thing is when the schedule's not adhered to, especially given that we have all these systems in place now to predict what's going to happen. And the other thing that was interesting was just the frustration of whether load shedding is one word, two words, or hyphenated. So
wow,
that came out when putting this presentation together.
We can do a whole presentation on that.
On that alone, I'm sure we can, right? So the problem statement, essentially, I need even more convenience. And when I say even more, beyond the EskomSePush app that we've got now, for checking when load shedding is on at home, right? So I have multiple Alexa devices throughout the house. We're a family of 4, and you just can't have too much convenience on this issue, right? So the reason to tackle it is because it's cool and very easy to do these days, especially given that EskomSePush has released a cool and easy to consume API on the matter, right? Tech stack, Amazon Alexa with the associated SDK, Lambda functions, as mentioned earlier. I used Python in this context, Google Sheets for some config, and then obviously the EskomSePush API, right? Now, how it works, I am going rogue, but like our previous teammates, and I am going to do a live demo. And in fact, I'm going to go even more rogue because I do feel under pressure given the quality of the previous presentation. So I'm going to take a few risks here. So to orientate the context, this is the live schedule as of a few minutes ago, which I uploaded from my phone. I'm in Broadacres. You can see we've got load shedding stage 3 at the moment, and we've got 2 more load shedding events scheduled. I also have Santon configured, but by default, Alexa is going to simply provide the load shedding schedule for the first one that I have configured. So the way to trigger the skill, they typically call this a skill, whole story as to why it's an Alexa app, is to say, Alexa, ask my power schedule. And that launches the skill and tells you what load shedding is scheduled. So Aretha, I'm going to ask you to come in here and help me trigger this skill. I want to see if it's going to work. So I've just messaged on Zoom the trigger phrase. So my Alexa's currently on mute. What I'm going to do is I'm going to stop sharing the screen so that you guys can see the device. Let's try. Okay, so the Alexa device is here. The speaker's here. Okay, so
are we ready?
I'm going to take Alexa off mute, and then you can try trigger it. Let's see if this is going to work.
Alexa, ask my power schedule. Oh, is anything happening? Should try again.
Scheduled over the next 48 hours in Broadacres. The first one is at 6 p.m. for 2.5 hours, followed by one tomorrow at 2 a.m. for 2.5 hours.
Okay, fantastic. Well done. Okay, so it worked. It would have failed spectacularly if it didn't. So let's quickly go through what happened then, how that works, right? So, okay, so that's Aretha on the left here, invoking the trigger phrase, which goes to Alexa. It goes through their infrastructure. I'm actually not sure where that infrastructure is hosted. I am curious to see where that is. It pauses that phrase and then decides what to do with it. In our case, it's been configured to call a Lambda function that fulfills this request. The Python code I've written, which acts as the intermediary, sits in this Lambda function. It makes a call to the EskomSePush API, brings back the data, and then parses that and converts it into the appropriate speech that we've just heard, right? And so, oh, just by the way, since we're here, we were told we have 3 load shedding events, the one that's on now and the other one that's happening at 2 a.m. And in order to make sure she's concise, I didn't, she only talks about the 2, although she informs us there's 3 within the next 48 hours, right? There's another missing piece here that I've not shown, and I'll quickly show. At the moment, she needs to know what suburb you're interested in, and that comes from essentially a Google Sheets config file at the moment, right? And she stipulates the first entry in that config file. So that's how and obviously you don't want to always specify. You want for convenience, you want to be as concise as possible. So you don't want to specify the suburb you're interested in. You want that as a default config. So that's how that works at the moment, right? Now, in terms of challenges, configuring one of the key challenges of exactly this, configuring the area for which Alexa will provide the schedule for is the tricky bit. And the ideal solution there is if there was a mechanism that that we could query the API for my profile and pick some default suburb that's configured in my app, then that would be the ideal way of having her figure out what suburbs I'm interested in, right? So in terms of what's next, there's clearly, this was done like super quickly, a couple of hours. There's hygiene factors, edge cases, error handling, etc., that would naturally need to be resolved. What one can also do is convert this, instead of a skill that you invoke this way, you can convert it into a news service or briefing service. So in the morning, Alexa can give you a summary of the news, and you can turn this into an RSS feed so she can give you what the load shedding schedule is proactively in the morning as part of the morning briefing. There's plumbing to do that. The third thing that can be done is to actually release this as an official Alexa skill as part of the EskomSePush apps, let's say, on the Alexa store. To do that, though, we'd need the ability to link it to some kind of EskomSePush account using. Alexa does have infrastructure to do this when you install a skill, but fundamentally it would require an OAuth mechanism to allow the user to link the accounts and to then pull the appropriate suburbs configured for that particular user, right? So those are pretty, those are within reach, but they would require time to achieve those goals. Nothing too extensive, but yeah, a bit of focus. And then lastly, the really cool thing that I would want to do with the API, and that I will do soon enough, is it's a different use case, but it's to set my battery backup levels. I've got full backup at home, to set it to the appropriate level depending on the load shedding schedule. I don't always want my battery fulls because I want to harness extra solar power. And so you wanted to dynamically adapt the battery reserve level based on the Eskom schedule, your expected consumption production. So to me, that would be the next incarnation of using the API accordingly. That's it. Getting in touch. I'm not sure if we'll be sharing these. I assume we will. And any questions?
You have one comment from Balaz in the comments, just about using the Alexa API to get your location and return a GPS, which they then feed into the EskomSePush API to connect to your area. Yeah, it's a good comment. I did look at that. So there's two things. You can get a geolocation if you're using a device on a mobile phone, or you can get the actual address as well. And then you need some mechanism to map the address to because you need to do a lookup to the suburbs or areas that the API is expecting. But it is a very legit path to explore and to pursue 100%. And then that doesn't need the whole OAuth integration thing with on the EskomSePush side. Cool. Dan or Herman, do you guys have any comments?
I actually wanted to ask about the GPS thing. So, but yeah, it's super cool. I was wondering, look, I like this a lot, but I'm thinking about Alexa already does calendar support, right? So when you're already have like the schedule in your calendar, I guess it can also like automatically read you the calendar. And I'm trying to think about, because I would love to support stuff like this, but I just know the amount of support I would have to do over email, and people getting confused with Alexa is just not going to scale, right? So I'm always thinking about, is there a way where we can sort of get that information there in another way, which is easier to support? So have to think about it a bit. But I've been thinking about it after your message. I think you sent a message on Sunday, and I've been thinking about it.
Yeah, look, happy to discuss it afterwards. Yeah, I think I agree with you. It might be more hassle than it's worth. But yeah, just worth considering. I like the idea. Yeah, if you could put it, if you could populate some kind of schedule, which is perhaps another integration. You know, integration into Outlook and into Google Calendar, and then that's another way of conveying this information, which is actually pretty cool.
But yeah, because but the problem is then you will not know, for example, your kids, you said your kids also use Alexa, they will probably not be able to read your calendar, right?
Yeah.
So it's not a perfect solution.
Yeah.
So
and if your calendar's full, you're not going to get a view over the next 24, 48 hours, etc.
Exactly.
Right? So yeah.
Thanks, Andreas. And thanks. I know that this was the last, we put you on the spot with joining us today. So I'm really glad you pulled through and came and joined us and showed us your cool demo. Our last demo for tonight is from the Unplugged team. And Jana, I think you're doing the demo for us.
Yes, I'll be doing the demo. Can you hear me all right?
Yeah.
Okay, okay, cool. Let me just share my screen. Apologies if there's any like feedback loop between the different screens. I'm just gonna go over this presentation quickly, seeing as we are a little bit behind schedule, so I'll just try and catch up a little bit. So we're Team Unplugged.
Don't worry, Jana, don't feel pressure. We have enough time for you guys.
Okay, that's perfect. So starting off just from left to right according to the pictures, we're Jana, that's me, Peter and Andre. And then just a little bit about us. Coincidentally, all three of us live in Pretoria. We like to simplify things. And probably the most annoying thing about load shedding is how it's become a normal activity during our daily lives. So if we jump into the problem statement quickly, so remote working environments can be an admin nightmare, and load shedding obviously adds to the complexity of these working schedules. And ultimately, managers are accountable for subordinates' times. So why do we want to tackle this? We wanted to ease the admin burden that the managers experience by improving the transparency of when people are experiencing load shedding schedule, load shedding outages, purely because the ESP app currently only, as far as I know, only shows you your specific area or your specific account's load shedding schedules. So we wanted to minimize the manager or the effort required from managers to actually keep track of when all of their subordinates are experiencing load shedding. So the tech stack we use is quite a lot. I try to simplify it by just including the icons. Basically, we incorporated Slack as our main user interface, and then made two separate backends, one in C# and then one in Python using Flask, and we hosted the entire thing in GCP, making use of Firestore as our database. So just to give a name for the app, we're calling it the Unplugged bot, or Flown for short, which also stands for lack of another name. So how it works, I'm just going to quickly follow, for some reason, follow the the lead of everyone else in the past few ones and do a live demo for you. So I do have a backup plan if it does fail. I did use the commands previously just so we do have a working backup. Can everyone see the Slack interface? Okay, I see a nod. So basically the Slack interface is just used for your configuration and also retrieving your data back. So you have two setup commands and then one delivery command. So your first setup command is how you would set up your area for your specific account in a specific workspace. So you would simply make use of the suburbs command to specify a suburb, and that would just be followed by a name. So in this case, I'm just going to use Somerset. And basically what that does is it returns all matching attributes or areas for that keyword. Now, this is in a convenient to select drop-down list, and we can select any one of it. Basically, it just updates your account for the specific suburb. Now, if you go to schedules, the whole idea of the schedules was for managers to see more than just their own schedules. So when you use the schedules command, it'll show you everyone in the specific workspace that you're working in who has configured their schedules. So it'll give you a little bit of brief info just saying, okay, this is the schedule for today. We're currently in stage 3, and it'll give you a list of everyone who has been configured. Now to view all of their schedules, you simply click on the overflow to show you the specific schedules that they're experiencing for the day. This is done to try and minimize the amount of overhead and the amount of information that you're being presented with. Along with, you don't necessarily want to see everyone's information when you use the command to see the schedules. And this way you can quickly and easily just see the specific schedules that you want to see. Now, a different way of setting up your specific area is you could also use the GPS coordinates. This is just one of the GPS coordinates that I got from the documentation. So this will then give you a different subset of APIs. You can again just select any one of them, and that'll automatically update your suburb. And if you go back to schedules, you will be presented with the updated schedules. So that's more or less the actual demonstration part of it. Okay, so I'm going to simplify this as much as possible. I do have 3 other diagrams that go into a lot more detail, but I'm following the trend of the others. I think that might have been very overkill for these purposes. So basically what it boils down to is you have 2 separate sections of the app. So you have your scheduler side that periodically goes and checks, pokes the ESP API to, or pardon, let me rather just show on the diagram. Can you see my mouse pointer? Okay, so basically you have a scheduler that pokes periodically and that posts a message to PubSub. PubSub then goes to or posts a message to the Cloud Run backend, which then retrieves the current stage from ESP and checks whether the schedules need to be updated due to a stage change. If there is a stage change present, it'll go and basically pull from our Firestore database the entries for every user that configured the area, and then individually add them back to PubSub messages, so individually they can be updated via the Cloud Run again. Now from the Slack side, you send a message, whichever message. So let's go for the 2 configuration setups. So from Slack, you either have the suburbs or the GPS command that goes to a different Cloud Run. The Cloud Run then goes and grabs the information from the ESP API, depending on which one you're using, either suburbs or the GPS one. So that compiles a blockhead message and sends it back to Slack, which then renders in the nice dropdowns. Once you select it, it'll automatically post back to Cloud Run with the ID that you selected, and that will first off update your area in Firestore, but it'll secondly send a request or message to PubSub, which will then update your specific schedules depending on the new area you selected, because it doesn't help that you change your area and not actually update your current schedule. Now, the reason we had to throw PubSub in there in that update section is because, similar to the Discord API I mentioned earlier, Slack also has a 3-second wait time for commands to be executed. So some of the challenges that we encountered, as I mentioned, the Slack 3-second API timeout, which was fairly annoying to say the least. One of our initial ideas that we wanted to do was we actually wanted to update your Slack status as well. So when you're encountering or when you're in a load shedding stage, it'll automatically update your Slack status. However, we ran into a little bit of an issue with Slack personal user tokens and apps not getting them that easily. Next up was blockhead selects. So basically that's just the drop-down list that renders the options. Now you can either give it a static set of options, or you can use an external source, basically what we did in this scenario. However, the problem is it requires arguments. So you can't send over arguments, pardon. So the ESP app for both GPS and bytext both require that you send in some sort of information so it can actually narrow down your results. Otherwise, you'll just overload the API. But the external source component doesn't allow for arguments to be sent over. So what it would do is you can restrict it to only make a query within the data set that it already has after a certain amount of characters, but you can't necessarily use those characters as search arguments. So that was a little bit of a situation. And the final one is, I'm pretty sure that everyone has experienced this, is just differences between local and production, where something would work locally. You build your container completely, publish it. It's a working container on local, but the moment that you put it in, for instance, Cloud Run, there are some certain very specific, for instance, Linux underlying issues that cause your container not to start up. So that's an interesting one that we encountered. So as part of the what's next, so one of the interesting things that I encountered with the standard, there's a little bit of lack in standardization between the different API responses. So for instance, the suburb versus GPS APIs, if you inquire on the suburb API, you actually get a nice ID as well as a name for that suburb. But on the GPS, you don't get a name. So basically what that comes down to is in our dropdowns, in the one dropdown, you now have nice names for the suburbs, and the other ones you're working directly with the IDs, which is a little, it's not as nice for the users. Obviously, we could go and iterate through those entries and get the information, but that requires a lot of unnecessary additional requests just to formulate a nice name for the user to see. Basically, a second step that we would like to do is integrate the schedule update better. So like I said, we basically have a schedule on the one side that updates the schedules, and on the other side, we have pub/sub messages to update your schedule according to when you actually change your area. But it would be beneficial just to combine those two, so we make use of the same backend to update the areas that we use on the scheduler side. And then a final one would be actually just to expand on the Slack configuration UI, where you could, for instance, set up schedules. So for instance, when you would actually be or like to be notified in Slack via messages. So you can just send, okay, whenever I do have schedule or scheduled Slacks, rather than just leaving it up to the manager to actually type in the schedules command and look for the schedule, but to actually post a message to the channel and also say, okay, this person is now experiencing load shedding. Yeah, so getting involved. Here are Slack handles on the OfferZen channels, along with the repository where we have the code for both the scheduler backend as well as the Slack configuration. And then we more or less have fairly self-explanatory documentation in the repository as well. But if there is anything lacking, it should be fairly easy to find. That's about it.
Thanks, Jana. Okay, I'm also aware, guys, we're a little bit over time. We're only going to run 5 minutes over. So I'm going to ask either Herman or Dan to jump in with one comment for these guys, and then we'll move on to our community vote.
First thing, I like it a lot. One thing that is quite interesting is one of our paying customers, one of our business paying customers, the management angle or the HR angle of load shedding is super, super important, right? So they messaged their employees saying, this is when we know when you're having load shedding. Like it's sort of a mental game. I'm not sure I want to work there, but it's interesting. It's really interesting about that management angle.
Thank you.
I'm really glad to see our special guest Herman as well for tonight. Sweet. Okay, let me. Oh. Okay, so I also just want to say a big thank you to all of the teams who presented it tonight and who entered. And there are also some guys who entered projects who we didn't have enough time to run all of them tonight. So thank you everyone who took the time to build and share your learnings and get us all excited about solving these problems with EskomSePush. And so the next thing up is that we all get to vote. Shan's going to launch a poll for us. So you get to vote for your favorite demo tonight, and they'll also get to win an awesome OfferZen swag hamper. So they are in the order of the demos tonight. So if you're a little bit confused, just try to remember what order they were, if you like one of the early ones or one of the last ones. And we'll give you guys a minute to just read through and find your favorite ones. And everyone gets a vote, even if you were a presenter, but try not to vote for yourself. Okay, we're just waiting for 3 more votes and then we have our winner. Okay, it's very, very close, but our winner is Badgelife. Congrats, guys. And then, so we definitely want to keep running awesome events like this for you guys. Well, hopefully you guys thought it was awesome. If you didn't, tell us how we can make it better. Tell us what you thought of the event. We're here to create experiences for you guys. So your feedback's really, really important to us. So Shanna's also going to share in the channel, in the channel, and also in the Zoom link, you'll see our feedback form. Please, we really, really appreciate if you guys take the time to give us some feedback so we can improve on our events. And tell us what you think. And you can also win some socks. As Herman said, they don't make any money off the socks. And then lastly, if you aren't part of our developer community, I know a lot of you guys were new. We had a lot of glue code guys. So if you guys want to join and find out about more events that we run like this, then we'll also share the link with you guys to get involved and find out what we're doing. We run a Slack channel. We also have a newsletter where we share what we have been doing to learn from each other and also what's upcoming. And then finally, just a special thank you to Dan and Herman, who were super keen to just jump in with us and do something fun and cool, and have been really, really great and very generous with their time and their spirit and their API access. So we really, really appreciate you guys' effort. And it's been super cool to see what everyone has built with your API. And I hope it's been useful for you guys too, to get some feedback and see the cool ideas that everybody has. And then the last thing is that's a wrap, but we'd love to do a photo of everyone together with a little wave. So I'm going to stop sharing. I'm going to ask you guys, if you can, please turn on your cameras and we can do a little final wave. Shan, you're going to do the actual screenshot. Okay, cool. I don't know if we're going to
everyone ready?
Is everyone ready?
Yeah.
We're going to count to 3 and then we're going to do it.
Okay, 1, 2, 3. Go. Done.
Thanks, guys. And especially to those who had load shedding. Thanks for making the effort, sitting in the dark and joining us, Mary. I think Isak's gone, but he struggled through with load shedding. And Herman, thanks for bringing your little munchkin. I know it's hard with bedtime. My husband put 2 kids to bed as well.
I also just want to say thank you to everyone. It was super cool. And yeah, feel free to reach out. We are super overloaded and stuff, but we try our best to answer emails and things. Your API key, if it runs out, please go to our website and you can just request a personal access token and we just put into the, like, I think why you want to use it, just say OfferZen challenge or something like that, and I'll see it and give you a token as soon as possible. Okay. And then also Herman and Dan do actually have a EskomSePush channel on ZA Tech. So we'll also share those details in our community and you guys can join that channel and see what's happening and get updates on the API. Okay, thanks so much, guys, for all your time. I hope you enjoy the rest of your evening. I hope you don't have any load shedding. Mine's only at 4 a.m, so phew. But enjoy the rest of your evening. Bye, guys.
Thanks, guys.
Everyone.
Cheers.
Thanks, everyone. Cheers. Thank you.
Bye.